You need to accomplish routing between 2 or more VLANs. Well, this picture shows VLAN 10 and VLAN 20, 2 PCs, and you need to route between those 2 separate VLANs. How do you do that? Well, you can carry that traffic up to a router known as a router on a stick, or a one-armed router. From a physical perspective, it looks like a one-armed router, but you're going to see that it actually has 2 arms. That would be 2 VLANs from a logical perspective. So I'm going to open your eyes to what that means and 2 different ways to accomplish inter-VLAN routing. Here we go. Okay, here we are in Packet Tracer. Packet Tracer is a very cool network emulator. I'm very impressed with it. In devices, let's get 2 PCs. We're going to do this inter-VLAN routing scenario. For network devices, we're going to connect the 2 PCs to a 3650. And for the router to do the inter-VLAN routing, we're going to use a 4321, make it look like a router on a stick, or a one-armed router as it's called in a topology like this. We'll make some connections. There's only one fast Ethernet port to pick from on the PCs. We'll start at the highest numbered interface on the 3650. We will start at the lowest numbered interface on the 2 devices, the switch and the router. Click on the 3650. You go to CLI and it tells you it must be powered on. Drop this power supply module into that slot and then it powers on. There we go. Let's click on the 4321. This one is different. It's already powered on. Say no to the would you like to enter the initial configuration dialog, and it'll drop you straight to the CLI. Say the same thing to the 3650. Show interface, show IP interface brief. All these ports are adminned up. They're just protocol down down. We do have up up on the 2 PC ports, 23 and 24. So 24 is PC 0. We'll give it a description. 23 is PC 1. So we can look at that description real quick. There we go. 24 is PC 0, 23 is PC 1. So we are, let's go back to 24. Switch port access VLAN 10. Let's put that on VLAN 10. Go to 23. Switch port access VLAN 20. So show VLAN brief. We now have port 24 on VLAN 10 and port 23 on VLAN 20. Okay, let's create a trunk. Switch port trunk allow VLAN add 10 and 20. Switch port mode trunk. Switch port trunk encap.1q. Switch port mode trunk. Switch port trunk allow VLAN add 10 and 20. What am I doing wrong here? Oh, allow VLAN 10 and 20. Add would be just adding a single VLAN number. Okay, so let's see what we have here. Show spanning tree VLAN 10. We got port 24. Show spanning tree VLAN 20. We have 23. Why isn't the uplink? Oh, I think this port has to be no shut. Watch this. What port is this anyway? Do show IP interface brief. That is G000. So check this out. Show run interface G101. Show run, you can't do that. Let's just look at it this way. So it's configured for VLAN 10 and 20, but when you show spanning tree VLAN 10 and 20, we don't see the trunk G101 in the spanning tree for those VLANs yet. I think when we no shut this, we should. Look at that. We got that 101 up message. Now, look at that. Now it's listening, and it's going to be learning in a second, listening and learning. Learning, there you go. LRN, and it'll be FWD in a moment. Takes about 15 seconds to listen, 15 seconds to learn, and then it'll go green right here. There it is. All right, you could maybe use spanning tree port fast trunk to speed it up a little bit. You just have to be careful because it might create a loop in the short term until spanning tree can do its thing and catch up. Okay, so let's put IP addresses on these PCs. The PC, we will put it on 10.1.10. We'll give it a 10 address 255.255.255.0, and the default gateway 10.1.10.1. All right, so we'll leave it at that. And we can go to the command line. We have 10.1.10.10. And we're pinging our default gateway. Is there a way to do persistent pings? I can't remember if Packet Tracer supports that, and it looks like it does. You have to put the T before the IP address. Let's get over here to this 4321. Now, I want to explain something for a moment. I've had some questions come at me recently about how to configure the router in a Inter-vlan routing scenario. There's a couple different ways you can do it. You can do it with subinterfaces, or you can do it with SVIs, switch virtual interfaces. So in our picture, we have a switch, and we have a PC, They're in two different VLANs, VLAN 10 and 20. So obviously they can't talk. They're in two different isolated VLANs. And then we're doing a router up here. It's a one-armed router. It's one arm physically. Logically, it's two. You know, you just have to look at it that way. You need to look at it in a router picture. It really looks like this. The router's here. You have a PC here, and you have a PC here. Okay, so this would be a layer 1 or a layer 2 diagram. This would be a layer 3 diagram. This shows the subnets. This shows the broadcast domains as they appear to the router. Okay, so to make sense of it at a logical layer 3 routing perspective, this is what it looks like. Does this look like it has one arm? No, it's got two arms. It's got an arm here and an arm here. Well, what are these arms? Well, they're logical broadcast domains. They're VLANs. This is what a VLAN is. It's a virtual LAN. Okay, so I mean, you look at this one switch and you think, well, it's a switch. You know, it could be one broadcast domain or one LAN. Well, it could, but we're using VLANs. Okay, and so we've separated the VLANs, and we're causing VLAN 10 to flow up here, and we're also causing VLAN 20 to flow up here. Oops, excuse me, VLAN 20 to flow up here. So it looks like this at a logical layer 3 perspective. This is going to be 10.1.10.0/24. This is going to be 10.1.20.0/24. Okay? So your first challenge is getting layer 2 connectivity. Layer 2 bridging connectivity from here to here, and also from here to here. That's the first challenge in a Inter-vlan routing scenario, is to get your VLAN correct so that packets can flow from the PC across the forwarding plane of the switch up this trunk to get to this VLAN 10 interface in that router. An exact same thing over whatever you do to VLAN 10, you do the same thing to VLAN 20. It's just you use VLAN 20 instead of VLAN 10. Okay? And the two different ways to bring traffic into a switch is either untagged or tagged. From PCs, it's typically always untagged. All right, so that's where you get the switch port access VLAN command here. On the trunk, that's where you do the switch port mode trunk, switch port trunk allow VLAN 10, 20, switch port trunk in cap.1q. .1q is the standard whereby which we insert VLAN tags and Ethernet frames. And so back to the physical topology. It's a one-armed router because physically, when you look at it, it's got one physical connection. going from port G101 to port G000. So if you just walk up to this thing in a rack and you look at it and you see one cable, it's a one-armed router. But it's logically routing two different broadcast domains. And that's where this logical picture comes in down here. And the reason you use switch port trunk on the trunk is because you're sharing it for two different VLANs, okay? So for Ethernet frames to flow across one physical connection and be able to be differentiated, they have to be tagged with a VLAN number so that when they arrive at this device or this device, whether they're going this way or whether they're going that way, the network device can differentiate the traffic. It's like coloring the traffic. Literally, back in the InterSwitch Link ISL pre-802.1q days, there was actually a command on a Cisco router when you showed an ISL interface, and it actually said what color the traffic was. Well, that's what you're doing. You're coloring the traffic. So the color of the traffic from here to here is color 10, VLAN 10. It's tagged 10 here, and VLAN 20. The reason it doesn't need to be tagged here is because the device here doesn't need to know about multiple VLANs. Now, if this was a server in a data center with with a virtual switch inside of it, some kind of a VMware or some kind of hypervisor virtual type of connectivity going on inside here where you had multiple virtual machines and a virtual switch, then you would be trunking to it, and then whoever's managing this server in the data center would then be able to configure that virtual switch inside of here to receive different trunked Ethernet traffic and forward it to different virtual machine computers inside of that physical server. But this isn't a data center, it's just a PC. I just wanted to give you that concept because sometimes it's true that you tag traffic going to computing devices like servers. But in this case, it's a simple 2 PC scenario. The PCs are untagged Ethernet, and so when the traffic comes into here, the switch keeps it separate inside of its own virtual MAC table, its own virtual VLAN 10 bridging table. Okay, same thing for this PC. When the traffic comes in here, it keeps that traffic in its own separate virtual VLAN 20 bridging table. And we're going to look at those two different bridging tables in a moment. Okay, I drew this a little different for this next discussion. We need to decide how we're going to do the inter-VLAN routing on this router. You can do it with subinterfaces on the physical port, or you can do it with logical switch virtual interfaces known as SVIs inside the backplane of this device in the router logic. And so there's two different ways to do it. Now, in order for me to talk about this, you know what I'm going to do? I'm going to draw the multi-layer capability around this device. I'm going to draw a switch behind it to show that it's a large switch with a router inside of it. It's a multi-layer device. It can switch and it can route. Now, if you use G000.10 and G000.20 to do the routing, what you're doing is on this physical port, and you know what I'll do is I'll extend the routing logic right down onto that interface to make it look like the router is touching that physical port. Okay? If you do this, the packets, those Ethernet frames will hit here, they'll get decapsulated, they'll get routed across the routing plane and then get re-encapsulated from 10 going to 20, and you'll have good connectivity, and vice versa. Okay? But what you can't do is if you ever had a port on this switch, let's just say there was another interface that you wanted to put in VLAN 10, you couldn't do it. You could not add this to VLAN 10 across this bridging logic because you've terminated the VLANs on the physical port. Now, if you were to do this in another way by using SVIs, then we'll redraw it, And if you brought the traffic up into this router and you used SVI, or excuse me, VLAN, those are SVIs, VLAN 10 and VLAN 20, then you could bring that traffic through this forwarding plane up into the routing logic to VLAN 10, and then route across the routing plane to VLAN 20, come through the routing plane, across the bridging logic, and then encapsulate it and take it out to VLAN 20, and then you'd have good connectivity. And what you could do is, since you still have VLAN 10 and VLAN 20 flowing through the bridging plane of the multi-layer device, if you ever wanted to add another interface to VLAN 10 or 20, you could then add it to the bridging logic such that it could connect to VLAN 10 or to VLAN 20 at a layer 2 perspective. All right? So that's one consideration that you'll have to think about when designing your enterprise network and deciding, am I going to do routing on subinterfaces or am I going to do it on SVIs? And if you go with SVIs, you will have a MAC table for the VLAN traffic as it flows across the layer 2 bridge function of the multi-layer switch. You'll have a MAC table. You'll see the MAC addresses being bridged through there. If you don't use SVIs and you use G0/0/0.10 and 20.10 ditto.20, you will not have a bridging table. Those Ethernet frames hit that port, they're decapsulated immediately, and you'll have an ARP cache right there on those interfaces, but you won't have a bridging table. Going back a couple of steps, if you use SVIs, you'll have the bridge table and you'll also have the ARP table. You're always going to have ARP. You're going to have an ARP table for the whatever technique that you use to accomplish your layer 3 routing. You're either going to route when you route, you're doing a layer 3 function. So you're either going to route, do layer 3 on subinterfaces, or you're going to do routing on SVIs. The difference there is if you do SVIs, you have a bridging function as well that you can attach to later on with other interfaces. Okay? So that's the additional data structure, the bridging table that you have when you're using SVIs. All right, let's do this. Let's use subinterfaces real quick. Let's check this out. Okay, encap dot 1Q10. We should get pings back. There we go. Okay, and what about this PC? Have we even configured it yet? No, we haven't. That's the default gateway. The interface is going to be 10. All right. We'll try to ping our default gateway first. Hey, look, when you're configuring and then verifying and troubleshooting, when you're doing Inter-vlan routing troubleshooting, the first thing that's got to happen, go back to the layer 3 picture. The PC connected to a router, connected to another PC. You've got to get this VLAN 10 bridge domain functioning. After that's working, you got to get this VLAN 20 bridge domain functioning. After that's working, then make sure your end-to-end connectivity is working. But until this is working, if that's not working, don't try to move on to something else. If this isn't working, don't try to move on to something else. But once this PC can ping the default gateway, and once this PC can ping the default gateway, once those two things are true, then move on to the end-to-end inter-vlan routing. Inter is like interstate. Prefix inter means between, right? And so inter-vlan routing is going across this VLAN, across layer 3, and back down the protocol stack to layer 2, and then across that VLAN. All right, so first things first, make sure your VLANs are working. Let's get back over here. We already saw that VLAN 10 was working. Let's see if VLAN 20 is going to start working when I do this next thing on the multi-layer device. Just use the up arrow. Save yourself a lot of trouble, or even a notepad for goodness sakes. Okay, there we go. So we are pinging from each PC to the router, which means that maybe the PCs can ping each other. Let's see. If the router is doing its thing, and it's a pretty simple routing topology, now that means you can ping across the router. If a PC can ping the other VLAN default gateway, then you might imagine what's going on here. This PC was just able to ping through the VLAN across the router and hit this VLAN 20.1 interface on the router. So that's good. That says something, but it doesn't go all the way over to here yet. So let's do that. 10.1, 20, 10. Hey, it's good. We're good to go. When we trace route, we might see a couple hops, the router itself, and then the PC as the destination. 1, 2. Yep, good to go. Let's verify a few things. Show MAC table. Nothing. Look at that. What did I tell you? No MAC table when you're terminating the layer 3 on the sub interfaces. Okay, you're decapsulating Ethernet and routing it immediately as it enters that physical port. All right. Hey, let's do something real quick here. Let's. Where's my notepad? My gosh, I can't get a notepad to open up. Okay, let's verify show ARP. So you have your ARP entries of the two PCs, you just don't have a MAC table. Show IP routes, show IP routes connected. So you have 2/24s and they're both on the actual ports, the actual port with the sub interface. Okay, so let's do something real quick here. Let's convert this. Let's keep this ping going end to end from PC 0 to PC 1. And let's remove some of this stuff real quick. Oops. I thought I copied that. So we'll say no to that. We'll say no to that. And then let's put these IP addresses on SVIs. And let's just do it like this. Oops, I thought I copied that. Let's try that again. Okay, this will be VLAN 20. And all right, so we removed the sub interfaces, show IP route, show run. Okay, now we need to convert to a switch port. Can we make it a switch port? It's not a switchable port. Okay, well maybe that explains the extent to which we're going to be able to do inter-VLAN routing on a 4321. Okay, so interestingly on this 4321, you have a VLAN switch and you have what looks like MAC table capability. So it gives the impression that it can be a bridge But I wonder if the interfaces that are on here by default are not switching capable or not bridging capable. That's the indicator that I'm getting when I go here and type switch port, switch port. And so even whenever I try to show it, show interface switch port, it says it's not a switchable port. So I'm thinking you might be able to slide a module into this thing. Maybe you can slide a module in here somewhere, one of these. But you know what? That will be for a later video, or maybe one of y'all can comment on how to make the 4321 bridge Ethernet into the forwarding plane of the 4321 and accomplish SVI routing capability. But as it, at face value, what I'm saying is using those 2 gigabit ports on there, that's how you would accomplish Inter-vlan routing, the way that I just showed it, using subinterfaces. All right, well, that's all I got for this video. Look forward to the next one. Okay, I couldn't resist. Let's go. All right, so what I did was I took this module. It provides 4 switching ports. Look at that. So I figured, my guesses, I think, were accurate that you could probably use one of these modules. And sure enough, I grabbed one of these and I slid it into this module slot right here. It said you can't do it while it's powered up, so click this little button, power it off, then drop it over there, then power it back on. It boots up, and show IP interface brief now shows you have 4 more gigabit ports, 010, 011, 012, 013. Now, remember we were doing this command earlier, and I was typing switch, and I was typing switch port, and it says it's not a switchable port. Well, go to one of those other ones in that new module that I just put in, and look at that. It says they're switchable interfaces. Show VLAN brief. Oh, something else I did while you weren't looking was I learned that this is an old school way of configuring VLANs in Cisco equipment, VLAN database. Go inside VLAN database and type VLAN 10 and then type VLAN 20. That creates the VLANs. Then exit out, show VLAN, shows you that you now have a VLAN 10 and a VLAN 20. Now your SVIs, the ones that we copied and pasted into here earlier, now they are, excuse me, thought they were in show run interface VLAN. Thought I had those in there. Maybe I deleted them. Okay, let's copy this back into there. Show IP interface brief. So now we have VLAN 10 and 20, but they're up, down. And normally an SVI, one of the common reasons that an SVI will be up, down is because there's no trunks or ports. There's no physical interfaces, whether they're being trunked or whether they're untagged and assigned to a VLAN. There's no VLAN, no interfaces of those either types assigned to the VLAN yet. So you have to have layer 2 interfaces, at least one, assigned to a VLAN and be in a spanning tree forwarding perspective, I'm pretty sure, to make the SVI go up, up. So let's get over here and make that happen. What we're going to do, though, is we're going to unconfigure G00 from the topology. We're going to disconnect G00 and we're going to connect G10. So let's connect it to G010 is what I meant to say. Now, why did we get an inconsistent port type? Maybe because it's not configured yet? Let's look at the configuration. G000 is shut down. Oh, it's switch port mode access, that's why. So switch port mode trunk, switch port trunk, allow, it's already participating in VLAN 10 and 20, it looks like, just by saying switch port mode trunk. Let's not even configure anything else. Let's just see what we get. So it's switch port mode trunk, that's all I put there. And switch port interface, or show interface, excuse me, G010 switch port. And it says it is trunking all VLANs. So show spanning tree, VLAN 10, show spanning tree VLAN 20. Okay, 010 is participating in both of those. Show IP interface brief. We have both of those interfaces up. I wonder if the PC is pinging now. It is not, and I wonder why. So can we ping our default gateway? Oh, maybe the ARP cache needs to be purged. So can we ping our default gateway? We cannot. Show ARP or ARP-A, ARP-A. Now look at this. Go over here, show interface G000. Include burned in address 2B01. So the old interface we were using, E424 2B01, the ARP cache is still using that MAC address. Show interface VLAN 10, include burned in address. Ah, look at this. So I'm thinking that if we purge the ARP cache, we will be able to ping our default gateway once again. So we see that we can't. ARP-D, I think, purges the ARP cache. And look at that. We can ping our default gateway now. Our ARP is now updated with what the SVI's MAC address is. That was actually a good troubleshooting exercise. I'm glad it actually worked out that way so I could demonstrate that. Can we ping across it to the other PC? We cannot, probably for the same reasons. And let's pull up that other PC. Oh, look at that. It updated just when I was clicking over. So there we go. So we have Inter-vlan routing using SVIs. Show IP route now shows we have 2/24s on SVIs and not the physical port with subinterfaces anymore. And we probably have a MAC table. Now, what I meant by having two separate bridging tables is you can look at them in that perspective. Show MAC address. I'm surprised actually that you can't look at it from a VLAN perspective. Show MAC. Show VLAN switch. No. So on other types of devices, you can look at it from a VLAN perspective, and maybe you could just say include. No, you can't even use pipes. No. Okay, but the fact that these MAC addresses are preceded with this VLAN number means that they are isolated into their own virtual bridging. VLAN 10 can bridge to VLAN 10, VLAN 20 can bridge to VLAN 20, and then the routing has to happen at the SVIs. Right here. Those two interfaces there. That's where the routing happens. You can even shut down an SVI to see that connectivity is broken. Once you do that, the pings should stop in the background. And they sure do. They start timing out. Actually, I think that's just pinging its default gateway. We'll ping across to the other PC and show that it's broken. And then we will no shut, and the pings start flowing once again. All right, well, that was a good exercise. We saw that you can slide a module into the 4321 and accomplish bridging across that module, and then you can do inter-vlan routing using SVIs. All right, well, I'm glad I circled back on that before I closed out this video, and I look forward to the next one. Y'all subscribe if you like what you're getting from this channel. I'll try to put more out here at the CCNA level. I'm sure this is helpful for that. And of course, I have other service provider videos on my channel as well. So I hope this is useful. Like I said, subscribe if you want to get more of it. Turn on your notifications. Share it with somebody else that you think could benefit. I appreciate it. And I'll see y'all in the next one.